Hello. We will now continue with our discussion of Lesson 1 with the study of ratios as a means of comparing similar quantities. Can you give me an example of a ratio? What do we use ratios for in our everyday life? Suppose we say the CEO of a company earns $2 million and an ordinary worker earns $20,000. Is it reasonable for us to ask how many times is the earnings of the CEO compared to the earning of an ordinary worker? We are now using a ratio for comparison. Now, let us look at 3 cubes and find the volume of each of those. I have here a cube A of 1 centimeter side. Now, what is the volume of that? Can you write that down in milliliter? What is the volume of this in milliliter? Now remember, a milliliter is the same as a centimeter cube. So the volume of this will be 1 centimeter multiplied by 1 centimeter multiplied by 1 centimeter. That will be 1 centimeter cube, which is 1 milliliter is the volume of cube A. How about cube B? What is the volume of cube B? It is of side 2 centimeter. What that means is its length is 2 centimeter, its width is 2 centimeter, and height also is 2 centimeter. Can you tell me what is the volume of this in milliliter? It will be 2 centimeter multiplied by 2 centimeter multiplied by 2 centimeter. That is 8 centimeter cube. That is 8 milliliter. Alright, I want you to make a note of these and you're going to put it all together and send it to me, right? Okay, that's how you participate in a class. You have a third cube called C, and one side of it is 3 centimeter. Therefore, its volume will be 3 centimeter multiplied by 3 centimeter multiplied by 3 centimeter. How much is that? That will be 27 centimeter cube or 27 milliliter. Alright, I want you to answer these questions now. How many times the volume of A is the volume of B? Alright, I want you to do that on your own. How many times is the volume of A the volume of B? In other words, how many A's can be fitted in B? How do you do that? I'll tell you how we can do that. You got to do this on your own and send it to me. Volume of B divided by volume of A will tell you the number of times the volume of A is bigger than the number of times the volume of B is bigger than the volume of A. Alright, next one. How many times the volume of B is the volume of C? In other words, that is a ratio of the volume of C divided by the volume of B. See how a ratio works. How many A will fit in B? Well, that is the same as the answer here. Is that right? The number of A's that will fit in B is the number of times B is bigger than A. That is the ratio, the volume of B divided by the volume of A. And how many A's will fit in C? I want you to write down all those and keep it as a Word document. Alright, the volume of B is 8 times the volume of A. Is that right? That's right. That means 8 A's will fit in B. Now here we use a ratio to compare the volume of one object to the volume of another object. In fact, ratio is such a useful concept. We can use it in many other applications in our daily life. Now, I'm going to now ask you to do an activity. That is Lab 2, the study of ratio. Now, what is involved in it? What I would like you to do is, I have asked you to buy yourself a foot ruler. Well, a foot ruler will be a small ruler. You can buy it from any store. It's about that long. And make sure when you buy them, it is marked in centimeters, not in inches. There may be markings in inches also, but look for centimeter markings because we are going to use centimeters. Now, what is the lab I would like you to do? What I will be doing is, I'm going to do it now. I'm going to show you what I am going to do, and I would like you to do the same thing on your own and make your lab report as a Word document with all the information and email it to me. We will now do a lab to understand more on ratios. Now, you need a ruler or a tape measure marked in centimeter to do this experiment. If you don't have one, I have provided one here for you. What I would like you to do is print this page out, then cut this out. That is your ruler that has a length of 10 centimeter. Now, you see, you can be creative. What you can do is, you can cut this out, which has a length of 10 centimeter, and then take a piece of string and measure, well, the first 10 centimeter, 2 times 10 centimeter. If you measure 5 of these, that will be half a meter. And if you measure 10 of that on the string, that will be how many meter? That will be 1 meter. I would like you to do that so that you can get a string that is 1 meter long. Well, you have now a string that is 1 meter long, and of course, this that is 10 centimeter. You can now use this to measure large distances and small distances. Alright, what do I want you to measure now? Measure the length of your work table in centimeter. Measure the length of your work table in centimeter. I'm going to measure the length of my work table in centimeter, and I have the length of my work table. I got 1 meter, and then I've got a little more. I've got 110 centimeter. So I'm going to write this as 110 centimeter. But remember, this is going to go away from the screen pretty soon. Alright, because when I want to bring in my next step. So, you have the length of the work table, write that in centimeter. What is the next thing to do? Now, so write the length of the table in centimeter here. Measure the width of your table in centimeter and write that here. And I'm going to measure the width using this ruler of my table. I got it as 80 centimeter. So, the width of my table is 80 centimeter. My length is 110 centimeter. The width is 80 centimeter. Alright, so you watch me do this, and you've got to do that on your own later on. Alright. Now obtain the area of the table in centimeters squared. Area of the table in centimeters squared. How do you obtain that in centimeters squared? Well, the area of my table will be 110 centimeter multiplied by 80 centimeter, and I got it as 110 multiplied by 80, and I got it as 8,800 centimeters squared. 8,800 centimeters squared. Well, that is the area of my table. What's next? Now obtain the area of the table in meters squared. You need to now obtain the area in meters squared. Alright, write the length of the table in meter. In my case, the length, you remember the length of my table? 110 centimeter. And I'm going to write this as, can you tell me how many meters are there? That will be 1.1 meter. That is the length of my table. And what is the width of my table? The width of my table was 80 centimeter. That is 0.8 meter. Therefore, what is the area? The area is 1.1 meter multiplied by 0.8 meter. And what is that equal to? You know how to multiply decimal numbers. Now multiply 11 times 8, that is 88. And the answer must contain 2 decimal places. There you are. And so the answer is 0.88 square meter is the area of my table. So the area of my work table is 0.88 square meter. Okay? Now measure the area of your bedroom or whatever room you are doing the studies. Maybe the living room. Now that's the reason why I want you to make that string 1 meter long. Alright, measure the length of the room. Well, if you give me a second, I'm going to measure the length of the room. Alright, I'll be back in a minute. The length of the room, well, I just measured the length of the room. I got it as 5.12. Well, in centimeters, well, that's a big number for me. I got it as 5,180 centimeter. I want you to remember that number. The length of the room, I got 5,180 centimeter. Alright? Okay. And write that now in meters. If you got that in centimeters, how many meters? 5,180 is 5.18 meter. And the width of the room, I got 3,200 centimeter. That is 3.2 meter. And now, I want you to find the area of the room in square meter. That will be 5.18 multiplied by 3.2. Is that right? Okay, what is the area of the room? The area of the room is, if I remember those numbers, it'll be 5.18 meter. Alright, let me do it here. It will be 5.18 meter multiplied by 3.2 meter. What is that equal to? Well, 5.18 multiplied by 3.2, I got it as 16.58. 16.58 square meter. Alright? So the area of my room is 16.8 meters square. Do you remember the area of my work table? The area of my work table was 0.88 square meter. Well, don't forget this. This is 16.58 is the area of my room. I might forget. I got a very short memory with numbers. Alright, let's go to the next slide and do a ratio. How many tables can be arranged in the room without wasting space? Can you tell me how to do that? How many tables can be arranged in this room without wasting any space? That's a ratio. What ratio is it? It is the area of the room divided by the area of the table. So the number of tables is area of the room divided by the area of the table. Now, the area of the room, if I remember correctly, it was 16.58 square meter, and the area of the table was 0.88 square meter. Well, you need to use a calculator to do that. Alright? I hope you have access to a calculator. So that will be 16.58 square meter divided by 0.88 square meter. I got it as 18.5. 18.5. Well, my question is how many tables? I did not ask you to cut a table into two pieces. So how many full tables can be placed in the room without touching each other is 18 tables. You can put 18 tables in that room. Now, I want you to do this on your own for your room. So the number of tables is area of the room divided by area of the table. Alright? Now, if the height of your room is 3.2 meter, calculate the volume of air in the room. You see, you now know the area of the room. If you multiply that area with the height, it will give me, or it will give you, a measure of the volume of air in this room. Let me do that in my case. In my case, I'm going to use the area of the room. If you remember, it was 18. Well, you remember the area of the room that we had? I'm going to use a number. I think it was 86 point something. I'm going to say area of the room is 86 square meter. Well, I don't remember. I'm just using a number. Now, if this is the area of the room, multiply that with the height of the room, which is, I gave you 3.2 meter. So, you multiply your area of the room. Okay, when you do this, you will not be forgetting these numbers. I have forgotten it because all those numbers were left behind. So, area of the room multiplied by the height will give you the volume of air in your room. Well, let's get a number for that. What will be that number? That number will be 86 divided by, well, I do remember that was not 86, that was 16.3. So let me correct that. It will be the area of my room is 16.3 meters squared and the height is 3.2 meter. So that will be 16.3 multiplied by 3.2. The volume of the room is, let me do it again, 16.3 multiplied by 3.2 is 52.16. I got it as 52.16 cubic meter is the volume of air in the room. So now I know the volume of the air in the room in meter cube. Alright, the volume is area multiplied by the height. Now, if the volume of a basketball is 0.008 meter cube, how many basketballs will fit in your room? Isn't that interesting to find out? That's the ratio. What ratio? It's the volume of air in the room divided by the volume of one basketball. So, what was the volume of the air in my room? It was 52.16. So, I have a volume of the room divided by volume of the basketball. Volume of the room was 52.16 meter cube, and the volume of the basketball is 0.008 meter cube. And so, what will be my result? Well, that's a lot of basketball. That is 6,520. I will be able to fit in 6,520 basketballs in this room. Now remember, this is a very fairly large room. In your case, it may be different. So I can now fit in 6,520 basketballs in this room. So the number of basketballs will be the volume of your room divided by the volume of the ball. Now I want you to complete this worksheet like this with your activity and email it to me. That is a good lab work. I want you to take it seriously and do it very well. Alright? If you have any problem, please let me know. Alright. Let's now talk about ratio as a rate. Now what is speed? Speed is the ratio of distance and time. You see, distance divided by time is speed. That's a ratio. So a ratio of distance to time is speed. And look at the way we write it. Speed is distance divided by time. Now tell me, what is the unit for measuring speed? Distance is measured in meter, time is measured in second, so speed is measured in meter per second. Is that right? So speed is measured in meter per second. Now tell me, how do you convert kilometer per hour to meter per second? Kilometer per hour to meter per second. I'm going to show it to you. Give me a second. Well, I have kilometer per hour. What's the way I'm going to use that? Kilometer per hour has to become meter per second. What all I need to do is, on the numerator, write how many meters are there in a kilometer. Tell me, how many meters are there in a kilometer? A kilometer contains 1,000 meters. So, kilometer divided by hour is the same as 1,000 meters divided by. Tell me, how many seconds are there in an hour? There are 60 multiplied by 60 seconds. 1 hour contains 60 minutes and 1 minute contains 60 seconds. So, what you need to do to convert kilometer per hour to meter per second is to multiply by 1,000 and divide by 3,600. It now becomes meter per second. See how easy it is once you know your values. Alright, let's move on. You multiply by 1,000 and divide by 3,600, or simply multiply by this number, 0.278. 1 kilometer per hour is 0.278 meter per second. Another ratio that is of interest to us is density. Now tell me, what is the meaning of density? We say there are two substances here. I would say this is more denser than this. The meaning is, in a given volume, this has more material packed in it than this cork. I know when I take the cork, it is very light. In this volume, only a small amount of matter is packed. Whereas for this, in this given volume, a large amount of matter is packed. So what is the definition of density? Density is measured as the mass per unit volume. In other words, if I want to find the density of this, all I need to do is measure its mass and measure its volume, divide mass by volume. That will give me the density. Is that right? Mass divided by volume is the density. Density of an object is mass of the object divided by its volume. Alright, can you give me a unit for measuring density? What is the unit for measuring density? Mass can be measured in kilogram and volume can be measured in meter cube. So one unit for measuring density is kilogram per meter cube. Kilogram per meter cube. How many kilograms are contained in 1 meter cube? It's a ratio. So density is mass per unit volume. It is calculated as mass of an object divided by its volume, and you measure it in kilogram per meter cube. You can also measure the mass in grams, is that right? And volume in milliliter, and then the unit of density will be gram per milliliter. Alright, how will you convert kilogram per meter cube to gram per milliliter? Can you do that? Well, let me see if I can help you there. Kilogram per meter cube. I'm going to start from here. Now tell me, how many grams? I want to write this kilogram in grams. Tell me, how many grams are in 1 kilogram? Well, 1 kilogram contains 1,000 grams. So, I'm going to write it as 1,000 grams. And do you remember how many? Well, you know that a milliliter is the same as a centimeter cube. How many centimeter cube are there in a meter cube? We talked about that in the last lesson. A meter cube, remember, a volume, a meter cube is 1 meter multiplied by 1 meter multiplied by 1 meter. That is 100 centimeter multiplied by 100 centimeter multiplied by 100 centimeter is 1 meter cube. That is 1 million centimeter cube. You see? So 1 meter cube is 1 million. What is the way I'm going to write it? 1 million centimeter cube. So this works out to be 1 over 1,000 gram per. In place of centimeter cube, I'm going to write milliliter. So 1 kilogram per meter cube. 1 kilogram per meter cube is 1 over 1,000 gram per milliliter. You see, 1,000 of a gram per milliliter. Okay, let's move on. So, look at the way I wrote 1,000. 10 to the power of -3 is 1,000. So, a kilogram per meter cube is 1,000 of a gram per milliliter. You see, density is the property of a substance. when you talk about a substance like copper, no matter how big or small an object made of copper is, its density will be the same because it is copper. That means density is the property of a substance. Remember in our last class we were talking about the properties. This is brass. The density of brass is a property of brass. Similarly, the density of cork is a property of that material. So density is a property of a material. Now, a very interesting measurement that will be useful to know. Water has a density of 1 gram per milliliter. If you take 1 milliliter of water, it will have a mass of 1 gram. Interesting, is that right? So what will be the mass of 1 liter of water? How many of you can tell me? 1 liter of water. 1 milliliter of water has a mass of 1 gram. So if you take 1 liter, what will be its mass? How many milliliters are there in a liter? There are 1,000 milliliters in a liter. So 1,000 milliliter will have a mass of 1,000 gram. 1,000 gram is a kilogram. That means if you take 1 liter of water, I have actually 1 liter of water here. This is 1 liter of water. And if you measure the mass of this, it will be 1 kilogram. So now, tell me what is the unit of density in kilogram per liter? It will be 1 kilogram per liter. So 1 gram per milliliter is the same as 1 kilogram per liter. Okay. Now, let's now do a lab. Now, you notice that lesson 1 contains several labs. Now, as we go on to lessons 3, 4 and 5, there will be very few labs. So this is the time when we will be doing a number of labs. So don't get upset. Spend some time in this lesson, do some labs. So let's do a lab to measure density. I'm going to ask you to do one thing. Density is mass divided by volume. That means to find the density of an object, you need to measure its mass, you need to measure its volume. Alright? Okay, so you are given, I'm going to give you a few things. You are given a small piece of copper, a measuring cylinder, I will show you what a measuring cylinder is, and an electronic balance. So this is a small piece of copper, and this is a measuring cylinder, and this is an electronic balance. Now, I can show you all those things right here. This is the measuring cylinder. Can you see that well? Alright, this looks the same as the picture. And a piece of copper, well, I'm going to use a piece of aluminum. Alright, okay. And I will show you in a minute what an electronic balance looks like, because I need to change the settings here. Now write a paragraph on how you will use these equipment to measure the density of copper. Okay, I'm going to do that for you, okay, and then you watch me do this and then write a paragraph on how you will use these equipment to measure the density of that piece of copper. Okay, give me a second. Well, the first thing I need to do is to measure the mass of my sample. And here I have shown you an electronic balance. You see it's reading 0 gram. It's going to measure the mass of the sample. Now, this is the sample I'm going to use. Is that right? That's the sample. I'm going to measure the mass. Well, I want you to write down the mass. Now, here is the mass of it. What is the mass of it in gram? It is 65.4 gram. Well, I will make a note of that here on my board, that the mass is 65.54 gram. Now, what do I need to do now is to measure the volume. So, I need to now change the setting. So, give me a second again. I need to now find the volume of this piece of aluminum. Now, how do I measure the volume of that piece of aluminum? I have measured the mass. Now, watch me do that. I'm going to use the measuring cylinder. Now, here is the measuring cylinder. I suppose you can see that. Now, I'm going to remove that writing to make it easier for you to see. Now, that is the measuring cylinder there. Okay. Now, first, I'm going to put some water in it. Now, I just put enough water so that it reads, now, I don't think you can see that, but I can see it. It reads just 100 milliliter. So, write down the volume of the water I have put in is 100 milliliter. Make a note of that. So that is 100 milliliter. And what I'm going to do is, I'm going to insert this solid. I want to measure its volume. Now, what do I have here? Okay. Now, that's... Now, I told you 100. Actually, it was... Yes. That's 100. Is that right? That's 150. Okay, now that is very nearly 130. I got 130 milliliter. Well, my measurements are not very accurate because I cannot really read it well in this light. So, I got 130 milliliter. I'm going to write that on the screen for you. Now, the volume of water alone is 100 milliliter, and now when you put the solid in there, with the solid you got the volume of water plus the volume of the solid. Is that right? Now this is the volume of water plus the volume of the solid. So let's write down that. Now, volume of water plus the solid or the aluminum I have is 130 milliliter, and therefore what is the volume of the solid alone? It is 130 minus 100, that is 30 milliliter. See, that is the volume. Now, I have the volume and I have the mass. What is the mass I have? You can see density is mass divided by volume. Mass, I had 65.4 gram, and the volume is 30 milliliter. What do I get if I divide 65.4 divided that by 30? So that will be, I think I got, well, 65.4 divided by 30 is 2.2. So the density of this substance is 2.2 gram per milliliter. You see how we obtain the volume of the substance and how easy it is to measure density of a substance. Okay, now you can write your piece of paper. Is that right? You can now write a paragraph on how you will find the density of this piece of copper using all these equipment. Alright, now look at this little problem. If the copper piece has a mass of 28 grams and a volume of 3.2 centimeter cube, what is its density? I want you to do that on your own. Density is mass divided by volume. I've given you the mass, I've given you the volume. I want you to write the unit in gram per milliliter. First of all, write that in gram per centimeter cube. Then write it in gram per milliliter. And finally, I want you to write it in kilogram per meter cube. That's a challenge. Okay, I want to see how many of you will get that right. And complete this lab worksheet and email it to me. You can see we are doing a number of labs, and that's a great experience for you to learn good science. Alright, let's move on. We will now look at densities of some common materials. Alright, I'm going to give you density in kilogram per meter cube, and I want you to complete this table writing it in gram per milliliter. You know that in order to convert kilogram per meter cube to gram per milliliter, divide by 1000. Conversely, in the previous slide, I wanted you to write the density in kilogram per meter cube. If you have the density in gram per milliliter, multiply it by 1000, it will become kilogram per meter cube. Alright, water, the density is 1000 kilogram per meter cube. What is its density in gram per milliliter? Well, you know that. Aluminum, its density is 2700 kilogram per meter cube. What is its density in gram per milliliter? Copper, the density is 8960 kilogram per meter cube. What is its density in gram per milliliter? Iron, its density is 7870 kilogram per meter cube. What is its density in gram per milliliter? Well, you know, to convert kilogram per meter cube to gram per milliliter, what do? Divide by 1000. Lead, the density is 11,400 kilogram per meter cube. Write that in gram per milliliter. Look at mercury, 13,600 kilogram per meter cube. Write that in gram per milliliter. And the king of all the substance is gold. You know, gold is used for ornaments. Look at the density. It's 19,200 kilogram per meter cube. If you have 1 meter cube of gold, its mass will be 19,200 kilograms. You see? Write that in gram per milliliter. Alright, can you answer this? How many times the density of water is the density of gold? Okay, do this, and along with the lab worksheet, email it to me. Alright, so keep in touch with me continuously as we move on. We will now go on to discuss equations and variables, a very important concept in the learning of science. What do we use equations for? Equations are used to describe how one variable changes with respect to another. What does that mean? How does the amount of money you earn change with the number of hours you work? Can you write an equation for that? Alright, tell me, how many dollars do you earn an hour? Well, I'm going to give you a figure, an easy figure. Suppose you earn $10 an hour. What it means is, at the end of 1 hour, you get $10. At the end of 2 hours, you get $20. At the end of 3 hours, you get $30. So, if I ask you use A as the variable for the amount of dollars and T as the variable to represent the number of hours, can you write an equation between the amount of money you earn and the time, the number of hours you work? Well, it will look like this. I think most of you will have difficulty doing that. Does it agree here? Amount of money equal to 10 times the number of hours. You see, look at that equation. That equation tells you that the amount of money you earn is 10 times the number of hours you work. You work for 1 hour. When T equal to 1, the amount of money is 10. When T equal to 2, amount of money is 10 times 2, $20. When T equal to 3, the amount of money is 10 times 3, $30. Is that right? So here is an equation. Now, an equation is used to describe how one variable, the amount of money, varies with another variable. You see that? Okay, you can write equations for many physical situations like this. Now, how does the distance traveled by a car change with time? The more time you drive, the more will be the distance. Is that right? Yes. Now, we can write a similar equation. Let me show you an equation there. I don't know whether you can recognize this. Distance, if I do d, and v is the speed, then can you write it like this? Distance equal to speed multiplied by time. Now, speed is the distance you travel per hour. You say 15 miles per hour. So, if your speed is 15 miles per hour, the distance you travel in 2 hours will be 15 times 2, 30 miles. So, d equal to v times t, where v is the speed, is another equation how the distance traveled by a car changes with time. Okay. Now, variation of one variable with respect to another may be direct or inverse. What is the difference between a direct variation and an inverse variation? In a direct variation, when one variable increases, the other also increases. The number of hours you work increases, the amount of money you take home also increases. There is a direct variation. The number of hours you drive increases, the distance you cover also will increase. It's a direct variation. So in a direct variation, when one variable increases, the other also will increase. How about the inverse variation? When one variable increases, the other will decrease. Can you think of examples of inverse variation? Well, if you go with a certain amount of money to Las Vegas, the more amount of time you stay and gamble, the less will be the amount of money in your pocket. Is that right? An inverse variation. The more you spend, the less you have. So our life is full of direct and inverse variation. Now look at this. When you fill your car, how does the volume of gasoline change with time? You go to the filling station, now open the gas tank and start filling. Now with time, the amount of gasoline in the tank increases. That is a direct variation. Is that right? And when you run your car, what is the relationship between the amount of gasoline in the tank and the amount of time you run the car? The more you run the car, less will be the amount of gas left in the car. That is an inverse variation. So you must understand the relationship of direct variation and inverse variation. Let's see how we can represent these variations by drawing graphs. I hope most of you have an understanding of what a graph is. What is a graph? A graph actually is a picture showing how one variable changes with respect to another. For example, let me take our old example that we had. The amount of money equal to 10 times the number of hours. If you want to draw a graph, say on the x-axis I have time, 0, 1 hour, 2 hour, 3 hour, 4 hour, 5 hour. That is time, is that right, in hours. And on the y-axis, the amount of dollars, is that right, A in dollars. That will be $10, $20, $30, $40. Alright, look at this. When you work for 1 hour, you get $10. Work for 2 hours, you get $20. Work for 3 hours, you get $30. Work for 4 hours, you get $40. Now, look at the beautiful picture of that relation that we have done. The amount of money varies directly with the time. And if I draw a line, that will be a straight line. Is that right? I think all of you know in algebra, we use the equation y equal to mx plus b. Can you tell me what that equation tells you? Well, b is called the y-intercept, where the graph, now if I draw that straight line here, this line passes through the origin. Now what is its y-intercept? There is no y-intercept. So if a graph is passing through the origin, it has no y-intercept. Actual fact, a direct variation, A equal to 10t is a direct variation. There is no y-intercept. So this equation is of the form y equal to mx. So let's take away the b. Why take away the b? Because there is no y-intercept. So take away the b. Can you tell me, what does the m stand for? I'm sure you have heard about it. M stands for the slope. What does the slope tell you? What is the meaning of a slope? Slope is the rate of change. Now, look at this equation. The amount of money changes every hour. You put in 1 more hour, the amount of money will change by $10. Is that right? Every time you work 1 more hour, the amount of money you earn increases by $10. That is called the rate of change. So, for this equation, 10 is the slope. Slope is a measure of the rate of change. Okay, how do you find the rate of change? What all you need to do is, watch me do this here. Now, from 1 hour, you change the working to 4 hours. Now, how much did the time change? When you go from here to here, how much did the time change? From 1 hour, you change to 4 hours. The time changed by 3 hours. Now, in mathematics, we will use this notation. Look at that. Delta t. I'm going to write it as 4 hours minus 1 hour, and that's equal to 3 hours. Delta t, we use that little Greek letter delta. This is not two separate things. Delta t simply means a change in the time. You changed your number of working hours from 1 hour to 4 hours. So what is that change in the time? The change in the time is 3 hours. Now when you changed your time by 3 hours, how much did your earnings increase? How much did the earnings increase? Look at this. When you work for 1 hour, you only earn $10. When you work for 4 hours you earn $40. That means this is now the change in your earnings, delta A, which is 40 minus 10 is $30. So when the amount of time you worked changed by $3, how much did your earnings change? Your earnings changed by $30. Therefore, what is the change in the amount if you work for 1 more hour? If you now divide the change in the amount of dollars by the change in the number of times, that is a measure of the slope. Now, so how do you calculate slope? Slope is change in the amount of dollars, delta A, divided by change in the amount of time. That will be $30 divided by 3 hours, and you write it as $10 per hour, and this is the slope of the graph of this equation, A equal to 10t. That's a very important information. So let's keep that with you. We will use that as we go on. So the variation of one variable with another can be represented graphically. For example, how does the mass m of a substance change with volume? Now, if I keep on increasing the volume, the mass also will increase, because density is mass divided by volume. So if I want to write an equation for mass, that will be mass equal to density multiplied by volume. Now, watch this. I can write it as mass equal to density D multiplied by volume. Now, isn't this equation the same as y equal to mx? So, if I draw a graph of volume on the x-axis and mass on the y-axis, that will be a graph like this. If I measure the slope of that graph, the slope of the graph will give me the density. You see how simple it is. So, we got mass equal to density multiplied by volume means mass varies directly as volume. So, if you draw a graph of mass on the y-axis and volume on the x-axis, it will be a straight line where the slope of the graph will be density. Well, now when mass increases, volume also correspondingly increases. This is called the direct variation. Alright, so I'm going to continue this by discussing the graph in a minute. Alright, give me a second. It's 0.7. Well, the variation of mass of an object with volume is a direct variation. A direct variation, as the volume increases, the mass also will increase. And so, if you draw a graph of mass on the y-axis and volume on the x-axis, it will be a straight line, and if you measure the slope of that graph, it should give you the density of the substance. Alright, let's develop that further. So how does this compare with the equation of a straight line? Now, we got the equation of a straight line. We said y equal to mx, because we said the graph will not have a y-intercept. When there is no y-intercept, the equation of a straight line is y equal to mx. The graph of this is a straight line where m is the slope. That is the standard straight line equation which has a slope m. I hope you now understand the meaning of slope. Slope is a measure of the rate of change. When you work one more hour, you earn $10 more. That 10 is a measure of the rate of change, right? Okay, when you buy one more book, how much does the cost of your education rise? You see that? When you buy one more car, how much does the cost of the household expenses go up? It's the rate of change. When a company hires one more worker, how much does the cost change? You see that? All these are important. A company that manufactures, say, pens, they will always consider what is the rate of change. When you produce one more pen and sell it, how much does the profit increase? A rate of change. That is the slope. So, this is y equal to mx is a direct variation which shows y varies directly with x. That means the rate of change will be m, the slope. The graph of this is a straight line. Let's draw a graph here. That's y and that is x, and this will be the graph. As x increases, y will increase proportionately. And slope is a measure of the rate of change of y with respect to x. What does that mean? Well, you can understand it as the change in y divided by the change in x. You see, it's a ratio. Change in y divided by the change in x. So slope equal to change in y divided by change in x. And how do we write it? Change in y is represented as delta y. So delta y is a single quantity which stands for the change in the value of y. Delta x is again a single quantity which stands for the change in the value of x. So the change in the value of y divided by the change in the value of x is a measure of the slope. Now, here I can measure the change in the value of y, and here I can measure the change in the value of x. So delta y divided by delta x. Now, in algebra lesson, you are taught slope is rise divided by run. Change in the value of y divided by change in the value of x. Now, for density, we said mass equal to density multiplied by volume. Isn't these two equations very similar? If you replace your m by y and v by x, then d will be the slope. You see, y equal to mx and mass equal to density multiplied by volume are similar equations. So a graph of, when you draw a graph of mass on the y-axis and volume on the x-axis, you will get a straight line. Now like this, if you got mass in kilograms on the y-axis and volume on the x-axis, you will get a straight line. If you measure the slope of this graph, you will get the density of the substance. We are experimenting with one substance. So the slope of this graph is density of the material. Now the slope of the graph of m against v. What is the meaning of graph of m against v? It means a graph drawn with m on the y-axis and v on the x-axis. And what is the slope? Slope is the ratio of the change in mass to the corresponding change in volume. So slope is a rate of change. A rate of change is a ratio. So the slope in this case will be the change in the value of m divided by the change in the value of v. Now, if you represent that on the graph here, we will represent the change in m as delta m and the change in v as delta v, and therefore the slope will be delta m divided by delta v. And there is the change in the mass, that is the rise, and there is the change in volume, so slope will be delta m divided by delta v. I'm going to illustrate this using an example. In fact, you're going to do the next lab. As I told you, this is the lesson where we have a number of labs, and I want you to get that experience of doing the lab activities. Now, the lab is designed to understand the slope of a graph. How do we measure the slope of a graph? An important skill for any science student. Not only a science student, in fact, everybody is a science student, because our life, everyday life, is so much depends on the understanding of these basic things. Okay. Now, I'm going to give you some idea on something I did. I measured the mass and volume of 5 pieces of copper. I took 5 pieces of copper, one very small, then I took a little bigger one, I took a still bigger one, 5 of them. I measured the mass of each and the volume of each. Alright, and I'll give you those values. Here are the values. I measured the mass in grams and I measured the volume in milliliter. Now, you know how I measured. I used an electronic balance to measure the mass, and of course I used a measuring cylinder. I showed you how this is used to measure the volume, and I got these values. Now, what I need to do, what you need to do now is plot a graph of the mass values on the vertical axis, that is the y-axis, and the volume values on the horizontal axis. Can you draw a graph of these volume values on the horizontal axis and these mass values on the vertical axis, and then measure its slope to obtain the density of copper? Now, what I'm going to do is, assuming that you have trouble, I'm going to show that to you. Alright? Okay. Now, this is how the graph is going to look like. You've got to take a graph paper, or you can actually do it on a piece of paper, but do it well. Now, I have told you, in case you have difficulty making these things as a Word document, you can keep all the work that you do in a folder, and a week before you take the final, make sure that you do that. A week before you take the final, put it in an envelope and mail it to me. I will give you my mailing address. Okay? So if you have difficulty making Word documents like this, I will show you how Word documents are made in the introduction that I gave you for the course. Alright? And I'm going to mark my horizontal axis for volume. That is 0. This is 10. That is 20. That is 30. That is 40. And that is 50. And on the x-axis, I have the volume. And let me mark now the y-axis. That's 80. You see, notice I gave you convenient values. It goes in steps of 80. 80 plus 80 is 160. 160 plus 80 is 240. So I can go in steps of 80 here. 0, 80, 160, 240, alright, 320, 400. So on the x-axis I have the volume in milliliter. You need to write that. Volume in milliliter. And the vertical axis I have mass in grams. Alright, the first point was this: when the volume is 10 milliliter, the mass is 10 grams. So that is my first point. My next point is when the volume is 20 milliliter, the mass is 160. When the volume is 30 milliliter, the mass is 240 gram. When the volume is 40 milliliter, the mass is 320 gram. And when the volume is 50 milliliter, the mass is 400 gram. And now look at the graph. Isn't that a beautiful picture of my experiment? Now draw a line through those points, and this is the graph of the equation m equal to d times v. See that? Now let's take 2 points in order to measure the slope. I'm going to take this point, which is x equal to 20, y equal to 160. So that's the point. And I'm going to take this one, which is x equal to 50, y equal to 400. And I'm now going to use these 2 points to find the slope of this graph. And watch me do this. First of all, I draw that line. Why did I draw that line? Because the volume changed from 20 to 50. And when volume changed from 20 to 50, mass changed from 160 to 400. So let's now find delta V, the change in volume. What is the change in volume? Now this is 50, this is 20. The change in volume is 50 minus 20, that is 30 milliliter. That is the change in volume. And find the change in mass. The mass here is 400 gram. And the mass here is 160. Therefore, delta M equal to, you can see I've written it this way. Delta M equal to 400 minus 160 equal to 240 gram. So, delta M equal to 240 gram. Delta V equal to 30 milliliter. Therefore, what is the slope? Density is given by the slope of this graph, which is delta M divided by delta V. That is 240 gram divided by 30 milliliter. And look at the way, and that is 8 gram per milliliter is the density. That is a beautiful way to do the experiment to measure the density of copper. Alright, so I want you to do this on your own, and if you can do it as a Word document, do so and email it to me. If you cannot, leave the graph separately and you can mail it to me. All the mailings that you will do, I need to receive it before the final. So mail it to me 1 week before the final. Okay. So complete this work and email it to me. Well, that includes the mailing in part. Alright, I'm now going to go on to lab 5. And this one you are going to do on your own. The earlier one I did, and you simply copy or do it in your own way. Is that right? Let's now do a lab measuring density of water. Now what I want you to do is, I'm going to do the measurements. Well, I'm going to show you how to make the measurements. Well, you can see this is done electronically. So in distance learning, we got to do a lot of improvisation. So try and follow what I'm doing here. I used the equipment shown here to measure the mass and volume of different quantities of water. Alright? You got the electronic balance and the measuring cylinder. So look at the way I did this. I'm going to show you what I did. I measured the mass of the cylinder. I got 168 gram. Now how did I measure the mass of the cylinder? Well, what I do is first, without any water in it, measure the mass of the cylinder. Put it on the electronic balance. I've measured the mass of the cylinder. Okay. And then, What I did is, I put 10 milliliters of water in it. You see, it's rather easy for you to do because it's all marked in milliliter. So, what you need to do is, put in some water so that, you see this is marked 10, 20, 30, 40, 50. So, I put in some water until it came up to 10 milliliter, and I measured the mass of that water plus the cylinder. I got 179 gram. This is in gram. I should have written it there. Now, so please make this change here. Put in parentheses gram at the top. Mass is in gram. Now tell me, you need to fill in this part. Okay? I measured the mass of the cylinder alone is 168 gram. Then I put in 10 milliliter of water. I got the total mass of the cylinder plus this water, 179 gram. So what is the mass of 10 milliliter of water? Write it there. Then I put 20 milliliter. You see, all I did is, I first put 10 milliliter like this until it came to 10 milliliters. It's easy for me to do that. There you got, I got 10 milliliter and I measured the mass, I got 179. And now I want you to fill in that value. What is the mass of 10 milliliter of water? What did I do next? I increased the volume to 20 milliliter. I put more water. Now I have 20 milliliters of water. I went to my electronic balance. I measured the mass. I got 188 grams. So now you got to find what is the mass of 20 milliliter of water. But all you need to do is, from the total mass, take away the mass of the cylinder. That will give you the mass of 20 milliliter of water. Then what did I do? I put more water so that I got 30 milliliter now. I measured the mass, I got 199 grams. So now you need to write what is the mass of this 30 milliliter of water. I then increased the water to 40 milliliter. Now I have 40 milliliter there. I measured the mass, I got 209 grams. What is the mass of 40 milliliter of water? Calculate and write it here. I increased, alright, okay. I increased the volume to 50 milliliter and I measured the mass. I got 220 grams. And now, what is the mass of 50 milliliter of water? This number, take away the mass of the cylinder alone. And that will be the number there. And finally, I got 60 milliliter. And the mass I measured, I got 229. So, I hope you understand your task in here. Your task is, now I give you the mass of the cylinder alone and also the mass of water plus the cylinder. I want you to obtain the mass of 10 milliliter, the mass of 20 milliliter, the mass of 30 milliliter, and so on. And now you have the volume values and the mass values. I want you to draw a graph of volume on the horizontal axis, mass on the vertical axis, just the same way I showed you in the previous case. Alright? So, write down an equation connecting mass, density and volume of a substance. What equation will you write? I have given it to you that already. Mass equal to density times volume. M equal to D times V. Then draw a graph of mass on the vertical axis and volume V in milliliters on the horizontal axis. Then, once you have obtained the graph, choose 2 points on that trend line. Now, please, when you draw a graph, the points may not lie on a straight line. Let me show you. If you have points, suppose you get your graph like this. That's your M, that's your V. Your points happens to be like this. Now, do not join the points. That is not what a graph is supposed to be. You see, an experiment will always have errors. In my experiment, there were some errors because when I poured water, a little bit of it fell off and so on. That means my points, my experimental points, really do not lie on a straight line. So what you need to do is find the trend line. Now look at this. Now this is the trend line. In other words, it shows the trend of your experiment. Now most points are lying close to that line. That will be the trend line. Alright? So draw the trend line. Do not join the points. And then choose 2 points on the trend line and measure the slope by measuring the change in volume delta V and the change in mass delta M, and obtain delta M divided by delta V and calculate the slope. Now, what does the measured slope represent? What does this slope represent? The equation is M equal to D times V. So the slope must represent density. Alright, what will be the unit of that slope? You see, the slope will be delta M. Delta M is measured in gram. Delta V is measured in milliliter. So the slope will be in gram per milliliter. And finally, what is the density of water? In fact, that was what you are actually doing. Your experiment, you are measuring the density of water. What did you get your result? Now complete this work and email it to me. Alright? Again, if you cannot get the whole thing as a Word document, do what you can as a Word document. The remaining, the part, the graph and things like that, put it together, and all those works that you cannot email, put it together, and 1 week before the final, send it to me by mail. I will give you my mailing address. Alright, what is direct variation? We talked about it. When you fill your car, how does the volume of gasoline change with time? As you keep filling, the volume of gasoline in your tank increases. Now, the volume V of gasoline inside the tank increases with time. That is a direct variation. A graph of volume against time, if you now draw a graph of volume on the y-axis and time on the x-axis, it will be a straight line. With time, you are keeping the nozzle open, the gasoline is falling into there. So you keep it open for a longer period, the volume will increase. The gas tank gets filled up more and more. There, you got a graph of volume against there. Your gas tank is getting filled up. Is that right? Volume varies directly with time. As T increases, the volume V also increases. And here we have a direct variation. In fact, we now see a number of examples of direct variation. Can you guess what information the slope of this graph gives? If I measure the slope of that graph, what information will that slope give you? You see, have you ever gone into a filling station and you keep pressing and hardly any fuel comes out. You got to stay there on and on and on. You see that? The rate at which fuel goes into the tank is very small there. Whereas in some other places you open it, it gushes out. The rate at which the fuel goes in is very high. So if the rate is very high, this graph will be steep. If the rate is very low, this graph will be sort of shallow. So what information does the slope of the graph give you there? Well, the information is the rate at which the gasoline goes into the tank. Is it going at a faster rate or at a slower rate? Now, how about inverse variation? When you run your car, once you filled your car, closed your gas tank, all right, pay the bill of course, and drive on. As you keep driving, what happens to the volume of gasoline in the tank? Well, the volume V of gasoline inside decreases with time. You keep driving, as you keep driving, with time, the volume decreases. Can you tell me what the graph of that will look like? Can you draw a graph of that? If you draw a graph of V on the y-axis and T, the number of hours you drive, on the x-axis, how will it look? And what is the difference this time? Volume V will decrease with time. Such a variation is called an inverse variation. As time increases, the volume is going to decrease. Let's draw the graph and see how that's going to look like. You see, once you finish filling, the volume is not zero. The volume will be the full tank over here. That means that's the volume and that's the time. Now, this is the full tank. As you keep driving, the volume will decrease and decrease and decrease, and if you're not careful, a time will come when there will be no fuel in the tank. The volume of the fuel decreases with time, an inverse variation. Tell me, what information does the slope of this graph give you? Now, very often you understand that the slope of this graph is a negative slope, because as time goes on, the fuel is decreasing. Tell me, what information does the slope of this graph give you? Well, some people fill their car and perpetually they are on the road. Is that right? That means the volume of the gas tank, the fuel in the gas tank will become zero very fast. But somebody like me, who only drives to college and back, well, fills only once in about 6 weeks. Well, that's true. I'm not joking. Well, the graph for my car will be like that, you see. In other words, the rate at which I spend the fuel will be very small. So look at the information the slope of the graph gives you. Now, what is the difference between the red line and the blue line? Well, if the red line is my little Toyota Corolla, the blue line is somebody's SUV. That will use up fuel at a much faster rate than my little Corolla, which gives me almost 40 miles a gallon. You see why I'm able to use it for 5 or 6 weeks, a full tank. All right? So what does it mean if the graph is a horizontal line? Tell me, what does it mean? The graph is a horizontal line. You fill the gas tank and the volume does not change. Well, you filled it and left it in the gas station, forgot about the car, and you came back after 5 days and found the car still full. Well, that's a dream, isn't it? Well, anyway, that's the meaning of that horizontal line. Now my purpose here is to make you understand the meaning of direct variation, inverse variation, and the slope of a graph. Alright? All these are important information. Now, I think we discussed a lot of information in this lesson, in lesson 1. That is properties of materials, measurements, and so on. We are going to use this as the base for understanding science. Now, in the next lesson, we are going to discuss scientific method. And from then on, our discussions mostly will be on astronomy, geology, and so on. So the course is going to be very interesting. Alright? I hope so far you had no trouble. If there is any problem, please let me know and I will assist you in any way I can. Alright, I'll see you for lesson 2 later on.